and I will be leaving from here at tomorrow. I will be leaving from here.
Tomorrow is Friday. Okay.
Yes, sir.
I think within Sunday, Saturday, every student will come, I think.
Yes.
So after that, you will do offline classes, isn't it?
Yes, sir. From 21st we have offline classes.
21st. Okay, no problem. You just come. It will be better.
Yes, sir.
Where is other students? They're joining slowly.
Yes, sir.
Let me start, and I am going to the screen. Okay. Yesterday we have started the technique. Tell me name. Is it visible?
Yes, sir.
Yes,
Lower
sir.
upper deck.
So I told you in factorization method, this is the simple algorithm, but your main work will be depending on to factorize the given coefficient matrix into two matrices L and U. That is your main work, and for that purpose, it will have some trick or idea. For that purpose, we will start today's class with a numerical example. Let for the timing again, I am telling you, just try to remember that four line, how we are doing this rearrangement. Okay, such that we can able to solve. Suppose I am writing a question. Suppose x plus y plus z equals to 1 and 4x plus 3y minus z equals to 6 and 3x plus 5y plus 3z equals to 4. So this system is looks like actually sorry, coefficient matrix A, vectors, that x is the vector actually, x is column vector here, x is basically x, y, z. So Ax equals to B is the right hand side column. That is in matrix form, isn't it? That is the equation number 1. And you have to solve it. Okay. Solve this system. Now tell me, if I'll ask you with the help of Gauss elimination method or Gauss-Jordan elimination method, can you able to solve this system?
Yes, sir.
The two method you know, I think. With the help of that methods, you can able to solve. Now, how we'll solve with the help of value decomposition or factorization method? That is our target today. Okay. Now I told you your main work, you just separate that A matrix into two matrices L and U. So on the basis of A, what is the dimension of A here? 3 by 3 matrix. What is the dimension of the coefficient matrix here? A matrix is the 3 by 3 matrix, isn't it?
Yes, sir.
So you have to choose L, or you have to factorize A into L and U. That L and U matrix also will be 3 by 3 matrix, such that their product will build A. And for that purpose, you just consider in this way. You will consider, suppose initially you just take the variable by name. Lower triangular matrix means diagonal to below all the elements are non-zero. L11, L2, 22, L33. Suppose that is L21. That is L31, L32, and this is off diagonal elements are 0. This is looks like lower triangular matrix. Okay, and upper triangular matrix I am considering similarly same way, but above diagonal elements are non-zero, below diagonal elements are zero. Okay, so suppose this is the diagonal. One, suppose 1 1, and I am considering here u12, u13, u23, 0 0 0, like that matrix you have to consider. Variables. Okay, so one logic I would like to mention here: if you will take in lower triangular matrix diagonal elements variables, you just see in L matrix diagonal elements are L11, L22, L33. These are variable, that is you have to calculate. If L diagonal elements you will consider variable, then U diagonal elements will be 1 1 1 numerical value. Besides that, you may consider L diagonal elements 1 1 1. That time U diagonal elements will be U11, U22, U33, like that. That is the logic. And if I will multiply these two matrices, what it will build? What it will build? If I will multiply these two matrices, what it will build? It will build original matrix A, isn't it? It will build original matrix A. What is the A here? Coefficient matrix 1 1 1, 4 3, minus 1 3 5 3, isn't it? Are you getting my point?
Yes, sir.
So you know matrix multiplication. Can you able to multiply this? After multiplying, that, you just do the point-wise comparison of the original matrix, because basically it will also build 3 by 3 matrix. Whatever the matrix you will get here, you just see. Actually, that means whatever the matrix you will get here, that is also 3 by 3 matrix, and that is basically nothing but A. So you just do point-wise comparison along with the original matrix A. You will get calculated, and every numerical value of these variables you can able to calculate. And separately you can able to draw numerical L and U matrix. That is your work. Now logic is that if you will multiply these two equations, you will get here 9 element. Okay, in every row 3 element, here is also 9 element. And if you will compare along with this 9 element along with the original coefficient matrix, you will get 9 equation. Okay, let me do your work. Actually, you just try to do this matrix multiplication. Try to do this matrix multiplication. So what will be the first position? Row by
L11.
Okay. Quickly, L11. What will be second row by first column?
L11 U12. No, sir.
Second row first column, that is second element. Okay, no problem. Like the third row first column, third element first column. Okay, L31, isn't it? Try to write second column, first row second column.
L11 U1.
L11 U12. Okay. Second row second column. This is the second element. Okay.
So L21 U12 plus L22.
Plus L22. Okay, in that way you can able to calculate L31 U12
2 plus L32.
L32. Here L11 U13
L
L11 U13 L21 U13 L22 U23, isn't it? And last row, last column, that is the last element, that is L31 into U13, L31 U13, L32 L32 U23 plus what is the last L33. Okay. This is actually your matrix. First element this, second element this, third element this. Okay. This is 3 by 3 matrix. Okay. And this is nothing but this is the original matrix. This is the original matrix. So what is? If you will compare the position, it will give you the values. L11 is 1, L21 is 4, L31 is 3, isn't it? If you will compare. So L11 is 1, L21 is 4, L31 is 3. In that way, you can able to calculate first L11 equals to 1, L21 equals to 4, L31 equals to 3. Now L11 already you have calculated. So from this equation, you can get U12, isn't it? So
Yes.
what is this
1.
value? What is this value? 1.
1.
So and L11 is 1. So U12 1. If you will compare along with this element. So from this, you can able to get some other value. You just see and check. L21 is 4. U12
-1.
So you just see if this value is
Minus.
okay. You just check and verify. Actually, my logic is I have taken this is variable. Okay. L11, L22, L33. In U L matrix, you do have 6 unknown, and in U matrix, you do have 3 unknown. Okay. So how many unknowns you do have? Total 9 unknowns you do have. And here, after multiplying this, it is giving you 3 by 3 matrix. And if you will do compare along with point-wise position, it will give you 9 equation. So to get the unique answer, only one unique value of L and U, all L and all U values, you need 9 equation for 9 unknown. This is the logic. To get unique solution, number of variable and number of equations should be same. That time you will get the coefficient matrix determinant value non-zero, then you will get the unique solution. That is the idea. And that is why if you will consider L diagonal elements variable, then you should consider U diagonal 1, 1, 1. Otherwise, you may consider U diagonal 1, 1, 1. That time, sorry, L diagonal 1, 1, 1. That time, U diagonal you will consider variable U11, U22, U33. In some book or in some other sources, you may get sometimes the LU decomposition method. U variable, U diagonal elements are considering variable. So don't hesitate about this. There is no restriction. Which variables you will consider, which matrix variable diagonal elements you will consider variable and which one constant. There is no strict rule written in the books. You may consider L or U, whatever, one variable, another 1, 1, 1 to get unique solution. If I will consider in both diagonal elements variable, then our number of variable will be, if this simple logic, if in both matrix I will consider diagonal elements variable, then our number of unknown will be how many? 6, 6, 12. Are you getting my point?
Excuse me, sir. Can you please repeat it?
Why I have not taken this U matrix diagonal element U11, U22, U33? Why I have not taken? If I will consider U diagonal also variable, looks like L diagonal I have taken here, looks like that. Why I have not taken here U11, U22, U33 like that? Why I have taken here constant, simply 111? For that purpose, I am telling you, if I will consider here is also U11, U22, U33, then total how many unknowns will be there in two matrix simultaneously? In L matrix 6 and U matrix 6, so total will be 12 unknown. Okay, 12 unknown will be there. And if we will compare point wise along with this matrix and this matrix, you will get simply 9 equation. So 9 equation, 12 variable. Can you able to solve? Infinite solution system you will build here. So you will not get the unique solution of all L values and U values. That is the logic. And that is why one diagonal constant, another diagonal variable. If you will consider L1, 1, 1 like that, then you will consider here U11, U22, U33 like that. That type of logic is here. Okay. So I am telling you, in some book you will get L matrix here 1, 1, 1. Don't hesitate. That time you will see there U matrix is variable U11, U22, U33. So whatever you may consider, it will not hamper. One will be variable, another will be constant, and that constant is 1, 1, 1 for the diagonal elements. Is it clear? Now you
Yes,
just
sir.
point. Okay. Actually, you know, for number of variable ज़्यादा हो जाएगा, equation कम, तो how many solution you will get? Suppose I will get for this system, I will get for this system unique solution. Suppose if rank of the coefficient matrix is less, then it will not happen. Means number of independent solution is that type of topics I am not discussing. Simply I am giving you or asking you this system only two equations. Suppose solve these two equations or solve only one equation. Can you able to solve? That time infinite solution system will exist. अब और भी थोड़ा सा डिटेल for example, if I'll ask you to solve x plus y equals to 1 and 2x plus 3y equals to 2, can you able to solve this? Can you able to solve this? Is it clear? Can you able to solve? Quickly say yes. You can able to solve. Now, if I'll ask you solve this equation, x plus y equals to 1, what is the solution then?
It's an infinite solution. No?
It's infinite solution. That time your solution structure x equals to 1 minus y. You may consider y infinite times many value on the real line. You will get x infinite value. Okay. So whatever y you may consider, x will be 1 minus that y. So you may consider y infinite times x will be infinite. So solution structure is infinite. So you will not get unique solution. Why? Basically two unknown and equation only one. So number of you understood the logic. Number of variable or unknown is more, equation is less. You will get infinite solution. That is the simple logic. So in both matrix, if we will consider diagonal elements variable, then in this both matrix, if you will consider diagonal elements variable, here is also variable, then your number of unknown will be 12 in L matrix 6 and U matrix 6. And after multiplying this 3 by 3, you may compare only along with this 9 element, means you will get only 9 equation. 12 unknown, 9 equation. Can you able to get unique values of all L and all U? That is the infinite system you are creating here. So you will not get unique solution of L and U. So you will not get unique solution of this system, means you are doing wrong things. And that is why one diagonal is constant, another is variable. Such that I do have here in both L and U matrix only 9 unknown, and after comparing I will get only 9 equations. So I will simply step by step all L values and U value easily we can able to get, and that values are unique. Okay, that is the logic or nothing else. Compare this. What is you want to? You want to compare this value along with this 3. This is 3, isn't it? So what is you want to already calculated 1.
-1.
This is 1. L21 already calculated 4. So L22 is
-1.
L22 is -1. So compare this value. This value is actually 5, isn't it? This is 5. So L31, you know, this is 3. This is 3. U12, that is already calculated 1. 3 into 1, 1 plus L32. Then L32, how many values is coming? 3 into 1 means 3. L32 is 5 minus 3 means 2. Bolo.
Yes, sir.
Bolo.
So U13 now.
U32, this value. Actually, this value I am comparing along with the 5, isn't it? This value, what is this value? Total value is 5.
2, sir, 2. L32 is equal to 2.
Okay, so that is actually I am telling you quickly. Quickly tell me the another how many variables we have calculated. 6 variables already calculated. And in this 6 variable, how many? Again 3 variables I need. So only. So L33 all L value already calculated. Only L33 will come from here. Okay. L33 will come from here. 5 L values already calculated. Only 6 L values is there. Only and 3 U values is there. Okay. To compare these values. Okay. This value is 1.
1, sir, 1.
So U13 is L111. So that is also 1. Compare this along with the -1. Okay. So this -1 L21 already you have calculated 4. This is 4. This value is U131 plus L22 already -1, and this is U23 you will get from here. Okay.
Plus 5.
Plus 5.
Yes, sir.
2, 3, 5.
These are the AI.
Values 2, 3, 5. No problem. And how many? Still one value is left. That is L33. That will come from here. And what will be that value? That is all these values are known. You just already calculated here. L33 you just tell me. L33
-10.
minus
10.
So 9 value already calculated. So you may able to construct L and U separately with these numerical values. What is L? Tell me L.
L.
L matrix you just write down. A equals to basically L U
1
and
0.
L matrix. Just a bit. I am writing diagonal elements 1 minus 1 minus 10. 1 minus 1 minus 10. Both diagonals are L21 4, L31 3, L33 minus 10, L32 is 2, isn't it? This is 0, this is 0, this is 0. That is L matrix. Similarly, U matrix also you just write down. What is the U matrix? 1. What is U1 to 1? U1 3 1. 0 1. What is U2 3? 5. And these diagonal elements with 0 0 4. In that way, I have considered it. These are 1 1. Only these three value you need. So then now you just use your algorithm. This algorithm. LUAX equals to B, then LUX equals to B. Consider UX equals to Y. Then LY equals to B. So that 4 line again and again you will write. Okay. Let AX equals to B, LUX equals to B. This is not let, actually given. Say UX equals to Y, then LY equals to B. So you just calculate from here all Y and you just substitute here. So LY let. So Y also is unknown vector. That is on the basis of given X. What is the dimension? What is the dimension of X? X is column vector. X, Y, Z is there actually. Sometimes X1, X2, X3 will be there. Okay. So in that way, Y is also you have to consider same dimensional. Y1, Y2, Y3. That is basically Y. Yes. How many dimensions in the given system will be there? On that basis, that dimension will be the same as Y. Actually, this is the vector representation. All expressions 1, 2, 3, and 4. Okay, so calculate all Y from this last equation. That is your fourth equation. Substitute in 3. You will get all X, and that is the solution. And that work already you have done. That is your main equation 1, and that is you have rearranged. Is it clear?
Yes, sir.
So you just write down let LY equals to B from 4. Like that, in that way, from the algorithm from 4. L.
Sir, for Z also we will do.
What is Z? LZ, where is Z?
X, Y, Z is here in the equation.
Actually, I am telling you this X is matrix representation. X is nothing but here vector. X is column vector. That is I am telling you.
Yes, sir. Got it.
That is the coefficient matrix. X is the column vector. Again and again I am telling you. That is not original X. That is not this X. That is the column vector. In matrix way, I have written this relationship. Okay. Sometimes you will get X1, X2, X3. Here it is X, Y, Z. So that is the column vector. Its dimension 3 into 1. So same dimension of Y you have to consider here. So Y3 unknown you may consider, Y1, Y2, Y3. That unknown you have to calculate from the last equation using the L matrix. Okay. L is 1, 0, 0, 4, minus 1, 0, 3, 2, minus 10. You have considered Y, Y1, Y2, Y3. And what is the actually Ly equals to B? B is the right hand side. What is the right hand side there in the question? 1. In the question it is 164.
Original matrix, no?
164. Tell me, from the fourth substitution, step by step, from the first equation you will get Y1. If you will multiply this row by column, you will get simply Y1 equals to Y1 equals to 1. What is the Y2? From the second equation, 4Y1 minus Y2 equals to 6. 4Y1 minus Y2 equals to 6. So Y1 is clear. So you may get Y2 easily. So Y2 equals to minus 2. After getting Y1, Y2 from the third equation, all three variables are there. You just substitute these two values, you will get Y3. What is the Y3? Y3 you will get from the last equation. Okay.
Yes, sir.
Multiply this 3y1, 3y1, 2y2 minus 10y3. What is this? Row column. Actually, that is equals to 4. So what is y3?
Half, sir, half.
Y3 is half. So 1 minus 2 or y3 is simply half or minus half?
Half only.
Nicely, you just calculate.
1 minute, sir. -1, -10. +5 to minus half.
Y3 is minus half. So actually in equation 3 you have considered y. You have considered y. That y you have got or already calculated with the help of this equation. That y is already calculated. So use that value in equation 3. So ux equals to y. Now ux equals to y. Y already calculated and x is the column vector. Y is, what is the y? Y1, Y2, Y3. So 1 minus 2 and Y3 is minus half means minus 0.5. Looks like that type of things I am writing. Okay. And U matrix is this upper triangular matrix. So 1, 1, 1. Okay. 0, 1, 5, 0, 0, 1. That is our upper triangular matrix already consider or construct. Okay. And algorithm is telling you ux equals to y. X is the unknown vector. Unknown vector is in column way you have to write x, y, z. That is the vector actually. That is you may write capital X, no problem. Equal to right hand side y. Y. That is you have calculated. So what is the y? 1 minus 2 minus 0.5 or minus half. Okay. So you just see this is looks like the last step of the Gauss elimination method, isn't it? From the last equation, last variable will come, isn't
Yes,
it?
sir.
And from the last equation, because row column, if you will multiply 0 into x, 0 into y plus 1 into z, means z equals to this value. So z equals to basically minus 0.5. From the second last equation, y and z is there, and z already calculated. So y will come out. Then y will come out.
-1.
What is the y? So actually y plus 5z, y plus 5z equals to minus 2. What is y?
-2.25.
Minus
2.25.
I think it will be simply half. You just try to calculate. Y actually z is minus. Z is minus. If you will bring this, z is minus half. Okay, z is minus half means 5 by 2 minus 5 by 2, that will be right hand side, plus 5 by 2. 5 by 2 means 2.5. 2.5 से तुम्हारा 2 हट जाएगा तो प्लस 2 रहेगा. Okay, z already calculated. Use z value here. Minus 0.5 means minus half. हाँ ये ना बोलो. After getting these 2 points from the first equation, x plus y plus z equals to 1. From the first equation, x plus y plus z equals to 1. And not 2 actually. Sorry, I have.
No, sir. 2.
Actually, it will be If you will actually use this value, this 5 minus 5 by 2, it will be right hand side, plus 5 by 2 means simply plus half. Okay. So yz is 1 is y1 is half, this is minus half, so this is plus half, minus half cancel, so x equals to 1. All three solutions for, so basically your main solution is x equals to 1, y equals to half, z equals to minus half. Actually, you have done right calculation or wrong calculation, you may substitute that value in original equation. Every equation will be satisfied. You just put that solution in any equation, it will be satisfied. Okay. Y is half, z is minus half, x is 1. Okay. First equation satisfied, y half minus half, x1, that is 1. You just put in this equation also, this solution is satisfied. Ab bolo, in understanding any problem, this method, actually very nicely I have told you. And simple example I have considered such that for every example you may able to calculate. Your understanding is very important. You understood or not, that is, you just ask me and tell me. Actually here, what is the arrangement I have done of equations? Actually, you just see. That is nothing but in the last class, what algorithm I told you. Actually, that is the logic I have used to solve this problem. Main work, A you separated by L and U after getting that rearrangement. Then Ux you have considered Y, that Ly equals to B, Y already calculated using fourth substitution, all Y will come out. Then use in equation 3, in equation 3 all X will come out. This is the matrix representation, okay, using back substitution method. Okay.
So this is the income variable.
अब बोलो समझ में आया कि नहीं? For any other example, can you ever solve? You just factorize your coefficient matrix into L and U, rearrange and find out the solution. Okay. So some restriction to use this technique, that is I am telling you. Actually, that is condition of to use these techniques, or as like iteration method we are telling that condition of convergence, like that. What is the condition such that we can able to use LU decomposition method and we will get the solution? So for that purpose I am writing simply note. You should write this. All the principal just हेलो 5 मिनट में फोन करते हैं. All the principal minors are non singular. All the principal minors of coefficient matrix. Actually, whatever this system, actually, its coefficient matrix is this. Okay. For any system, its coefficient matrix principal minor principal minors you do have. If this is 3 by 3 matrix, then it will have 3 principal minors. Suppose M1 equals to 1, that value. M2 equals to this value. This value means 1, 1, 4, 3. And M3 is the original coefficient matrix. Original coefficient matrix means original matrix. Okay. So first of all, we know for the unique solution original matrix determinant value not equals to 0, that is you know. So M3, determinant of M3 not equals to 0 means A is non-singular. And similarly, these two also non-singular means this M1 first value should be non-zero. This determinant value also will be non-zero. Then all the minors are non-zero or non-singular. So the non-determinant value non-zero, determinant value will not be 0 means corresponding matrices or minors will be the non-singular. Then you may be able to use that LU decomposition method and you will get the solution. You got my idea? What I am telling?
Yes.
Okay. If I'll ask you simple one question, suppose a system having the coefficient matrix, suppose 1, 1, 2, 3, and suppose 4, 8, 1, and suppose 2, 2, 3. No, whatever. A coefficient matrix is this, suppose, for a system. Suppose in first equation, x plus 2y plus 3z equals to something. Second equation, 4x plus 8y plus z equals to something. And last equation, 2x plus 2y plus 3z equals to something. So coefficient is matrix is becoming looks like that. Can you able to say in this system, its corresponding matrix simply I have written. In this system, LU decomposition method we can able to apply or not? You just write down all the minors. What is the minors? M1 means first element of that is it should be non-zero. Okay, this is satisfied. M2 second minor is 1, 2, 4, 8. It should be non-singular. Non-singular होने के लिए क्या होना चाहिए? Its determinant value should not be 0. You just see and check. Its determinant value 0. It is becoming singular. We no need to check M3. All I am telling you all. So determinant of M2 is 0. So it is singular. Eight minus 8, 0, isn't it? So therefore LU decomposition method is not applicable. What my point? बोलो वो समझ में? Only this is the condition you just keep in mind. And for elimination method, what is the condition I told you? Gauss elimination method, Gauss-Jacobi. Actually, whatever this equation number, corresponding variable coefficient should not be 0. Suppose first equation, first variable coefficient should not be 0. Actually, in this case also it is applicable. In first equation, first variable coefficient is should not be 0 because M1 should not be 0. M1 अगर 0 हो जाएगा तो basically first minor singular हो जाएगा. So we cannot able to use LU decomposition method. So that logic applicable here also. But in remaining equation also we have to see in that methods. in elimination methods. In second equation, second variable coefficient should not be 0. Third equation, third variable coefficient should not be 0. Here, all the principal minor should not be, their corresponding determinant value should not be 0. Means all the principal minors of the coefficient matrix should be compulsory, non-singular. Okay. Only one problem I solved. You just pick up the problems from the book or assignments or from anywhere, from the question also, and try to solve with the help of these methods the problems. Okay. In understanding any problem you do have, you may ask. Any query?
No, sir.
So we are ending the meeting now. Only
Okay.
lots of students absent.